Hello, hi, welcome to Upsana Classes. Today in this video, let's know about the 4-bit parallel. Before knowing that, let me tell you one thing. An investment in knowledge pays the best interest, right? So whether you earn or not with your knowledge, you will have a little self-satisfaction if you don't do anything or if you just share your knowledge. The knowledge is not only by the studies, it will be by the dance, the information that is known by the dance or any skills is nothing also but knowledge, right? Studies is not only knowledge, I think so. Okay, now 4-bit parallel. 4-bit parallel adder. So 4 bits I have to add parallelly. So to add 4 bits parallelly, I have to take 4 adders. I'm telling 4 adders. You have to tell me whether it is a full adder or half adder. We know that half adder adds 2 inputs, full adder adds 3 inputs, right? I would like to add, for example, 1 0 1 0 0 0 1 1. I would like to add input 1, input 2. Now tell me, it is a half adder or full adder? If you say half adder, it's wrong because you also have to add carry that is generating for each adjacent bit, right? So to add this carry, we have to use carry bits that are generated by every significant bit. So we have to take full adder as it is adding 3 inputs, 2 inputs. Okay, fine. A and B, that is our agent and addend, but the carry that is generated for each sequential bit, so we need to take full adder. So we have, as we are having 4 bits, we have to take 4 full adders. 4 full adders. Let me draw. Okay. 4 full adders. Adder 1, 2, 3 and 4. 4 full adders where inputs A, B, A, B, A, B, A, B. It is a full adder. I am naming as not. Full adder 1, full adder 2 and full adder 3. So accordingly, B naught, A naught, B1, A1, B2, A2 and then B3, A3. Then how we are giving inputs? 2. I said 3, but we have only 2. See, first our primary input C in. Primary input C in should be 0. If we add with 1, we are adding extra thing. So we would like to add 10 plus 3. We don't need to add any extra bits here. So for that, primarily we are taking as 0. So primarily C naught is 0. So C naught or C naught equal to Cn equal to 0. I am taking. So 0 plus 0 plus 1, we get 1. Let me write here first once. So 0, 1, 1. This is A, B. Not 1, 2, 3 representation. A naught is 0. A1 is 1. A2 is 0. And then A3 is 1. Next. B naught is 1. B1 is 1. B2 is 0. And then B3 is 0. Then carry, how we get carry? And then we know that a full adder will have 3 inputs and 2 outputs. Okay, see here 1, 2, 3. 3 inputs. Where are outputs? One for sum and one for carry. This is carry. This is its output, sum and carry. And where this C1 and this C1 become input to this full adder. and then it will again produce sum and carry, and this carry is again input to this, one of the input to this F2, FA2. So C2 and then C3 and C4, yeah, not 1, 2, 3 and 4 equal to C out equal to, let's see what we are going to get, and then sum not, sum 1, sum 2 and sum 3. So we take output of the 4-bit adder as C out, S3, S2, S1 and S0. So if someone asked you, so what is the output of a 4-bit parallel adder? You have to say C out, S3, S2, S1 and S0. This is our output of a 4-bit parallel adder. Okay, we have to consider this is the output. Okay, fine. So C in is 0. So 0 plus 1 plus 0. We get 1. So S0 equal to 1. Whereas C in will be 0. Right? So we get 1. We don't get any carry. As we don't get any carry, we assign carry as 0. Right? 0. So 0 plus 1 plus 1. So 1 plus 1 is 2 in a decimals. In binary we represent as 1 0. So 0 is assigned to sum, and that 1 then in the most significant bit we represent to carry. Okay. Now 0 plus 0 plus 1. What we get? 1 and the C3 will be 0. And then C 0 plus 0, 0 plus 1, 0 plus 1. We get 1 and that output will be 0. Let's see here whether we get the same output or not. So 0 plus 1, 1, 1 plus 1, 2, that is by 0, 1. So 1, 1. So 1, 1, 0, 1 and that 0, final 0, that is our carry here. Final carry, that also we have to consider. So 0, 1, 1, 0 is our answer. Let's see. 0, 1, 1, 0 and 1. Fine. Nothing but we have to give 4 full adders. Initially we have to give C in equal to 0, as full adder have 3 inputs. So AB, primary inputs, agent, addend, agent, addend, agent, addend and then agent, addend. And then primary input carry, primary carry. So primary carry that we that generated is 0. So 0 plus 0 plus 1. 0, 0, 1. So 1 we got. So 1 we got. But we got carry nothing. So as we got carry nothing, we assign 0 to carry. So carry got. So inputs and output. If you consider here, inputs, outputs. Inputs, outputs. Okay. So this is about the 4-bit parallel adder. You have to represent all the notations. So final answer will be C out. You have to consider also C out, because if you get 1 here, let me tell you, if you have 1 here, what will you get? Okay, if you have 1, you will get 1 0, right? 1 plus 1, 0 plus 1, 1, 1 plus 1, 0, 1, so 1 0 0, 1 and then 1 1 you get 1 0, 1 0. So also you have to consider this one, means C out. The final carry you have to consider. Okay, initial carry must be 0 and the final carry you must consider with the answer. So that is the 2 points you have to remember for the 4-bit parallel adder for 4 bits, because 4 full adders you have to take, because we need to add 4 bits. And parallelly adding means parallel. You will have a serial adder too, where in serial adder only one full adder will be used, and then 2 registers for both inputs. We have to use 2 register, and for output we have to use another register. And to store the carry sequentially, we use a D flip-flop in the serial adder. We will see in the next class. This is about the 4-bit parallel adder. Hope you understood. Thank you for watching. Please like, share and subscribe.